So I will be talking for Monty Bateman today, or at least this morning now. And I'll be discussing a little bit about the GLM proxy data and then relating it a little bit to what's going on in CHUVA and how the CHUVA analysis is going to contribute to creating GLM proxy data. GLM proxy data is basically artificially produced, real data fed simulations of what the geostationary lightning mapper will produce once it's up and rolling in 2015. Remove the microphone down. Is that better? We need these data to be able to create products and deliver it to forecasters and real-time users and the National Weather Service and researchers so they can be ready in the starting blocks, ready to go and understand what GLM will do for them, geostationary lightning mapper will do for them once it's up and part of the GOES-R system. So Monty's been working on the proxy data stuff for many years using an LMA that is in, well, various LMAs, but certainly one in Alabama. And so they have a lot of experience, and he has over the years developed a proxy generation tool using GLM, or using the sound, got to get my acronyms right. I don't give this talk every day. It's pieces of things, I understand them, but I got to get the acronyms together. So the Alabama LMA data and the LIS overpasses have been used to train this kind of proxy generation product. LIS is an orbital satellite that's been up for many years now and carries an instrument that measures lightning data from space, much like the GLM will be producing. So you use those two pieces together to create these proxy products. Now we have the opportunity to take other ground-based systems besides the lightning mapping arrays and create these proxy data products. We can't put a lightning mapping array in the middle of the Atlantic Ocean, so we have to see what sort of lightning data is available there, and from that, can we boost it up a little bit, understand the data sets, and create some proxy data that has spatial continuity from the landmass out to the oceans, and provide, for example, useful proxy data for the people that do forecasting over the oceans, the SIGMETs for the oceanic air traffic and things like that. So there's a need to use whatever kinds of data set you have. So use the long-range data sets over the oceans. In places where you don't have LMAs, can we now use the much better quality approximate total lightning systems that operate at VLF, LF, and towards HF? So that's where the CHUVA data sets really come in hand, because you've transported the orbital LIS, you've transported LMA, which they have comfort with, into Brazil, confirm that they perform as they should, and now you can integrate it with this full collection array of other ground-based data sets for producing proxy products. So that's the summary. I have a few slides that are going to give you a brief overview. I can't do what Monty can do because he's done this for years, but I can give you a brief overview of how the current proxy product generator works using VHF lightning mapping data, and then move on to a few other comments. So we've looked quite a while to find correlations, commonalities between the VHF mapping data and the LIS data. And the strongest hook that he can put on the wall is this histogram here, this two-dimensional histogram that you see here, which is the number of pixels lit up in the optical detector, the orbiting optical detector, versus the highest altitude or the median altitude of the flashes that are detected by the LMA systems. And that is the starting point. Because the first thing he has to do to create a synthesized flash is to reach into a bucket and pull out a number that says how many pixels are lit. So he takes the LMA data and he reaches into a flash and he says, oh, that flash has this altitude. And so with this altitude, I'll draw from this two-dimensional distribution, I'll draw an ensemble member, and that's how many pixels I'm going to light up. That's the first step. And that's the only thing. I think maybe Monty's going to come in and talk. Is that what happened there? Somebody maybe turned on a speaker. Was there a comment from Huntsville? So once he's pulled out those number of lit pixels, then he takes what you might call climatological data from the Liz and LMA correlations to build the shapes and sizes of the flashes that are going to be produced by the system. So he has to study the temporal and spatial distribution of those pixels. I'll call it climatological. As a catalog of size and shapes, and he's produced a couple of distributions that he thinks characterize the major attributes in space and time of these events, how he's going to organize these lit up pixels. On the left side here is a scattergram in orthogonal dimensions in increasing value from the left corner, normal Cartesian coordinates, of objects seen by Liz in order to understand the and LMA correlation, to understand as the object gets bigger and bigger, how circular is it, or how eccentric, how elliptical it is. And if every single flash was a circle, you would get a straight diagonal line with a slope of 1. So this is, again, a sort of a two-dimensional histogram that shows you that there's a little bit of leaning towards eccentric shape as things get bigger, but the flashes are mostly circular. That makes it easy. He can use that kind of constraint to produce spatial organization of the lit up pixels. On the right is a histogram of the time interval between discharges against the order of them within the event list. So if you have an event here, what's the expected time to the next one? And it shows that the time intervals are larger, the number of 2 millisecond time intervals, which is the resolution of the optical instrument, that you have from first to the second, second to the third, and so on. And they approach an asymptote of a fixed interval. I think that's 20 milliseconds is the horizontal asymptote. So once you get up to 20 members in this set that he has to temporally organize, you make them 20 milliseconds apart. But the early ones, you make them further apart. So he uses that sort of, we'll call climatological information to make those inferences. And from that, he does, essentially distribution matching, assemblage of ensemble members, and splattering out of data with just that original constraint from the real-time data stream that is being produced about height. They were concerned how that would work, so they generated several cases where they would take the LMA data, they would recluster the data, they would compare it to a flash algorithm that they have, and see if the synthetically produced data and the original data had merged or split flashes. And their statistics showed that 85% of the time the flashes were the same flashes from the synthesized data as the real data. 15% of the time flashes were merged, and 0% of the time were flashes split apart. So they felt good about the synthetic data approximating the general behavior of flashes. Then the question is there any information content, as in meteorologically significant information content in the flashes that they created? Chris Schultz had done his master's thesis looking for the lightning jump, which is a rate jump over a short period of time followed by a diminution in the rate. That's associated with severe weather events. Chris has a publication with a number of other NASA folks and Huntsville folks, and it's quite compelling. that there's a good spatial and temporal correlation with these lightning jumps, and they are a reasonable indicator of severe weather. So Monty's master student then took the synthesized data from the same data set, produced an equivalent lightning jump algorithm for the synthesized data driven by the original storms. And the algorithm worked just as well, and Monty says sometimes even a few cases better. Maybe he's done a little constraining of the data through the probability distributions. You don't have the tails in the distribution, so it's a little cleaner. So a word of caution, we're now moving on to saying, what do we do with these data from the ground-based systems to produce an alternate way to synthesize proxy data? And Monty wanted me to make the point that you have to worry about detection efficiency over the oceans. You have the woolen data, the GLD data. If the detection efficiency gets too low, you just can't boost it up statistically. You'll create a random animal, and it won't be a good proxy generator. So they have some concerns about that, but they certainly want to try it. In the U.S., he says that the Earthworks network detection efficiency can be extremely high, but then it can be low and bounces around. And the variability of that is going to create a lot of variability in the proxy products that you generate from it. So the take-home story for people there is, for the ground-based networks, is to manage your network quality. You don't necessarily have to produce the most dots. You have to produce the dots that provide a good temporal behavior, so that, at least for the proxy product generation, so that you've got something that carries the overall average behavior of the storm, and that it's stably reproducing reflecting what's going on. I'm going to have to skip this, but I have one of these. This is one of Monty's plots. The story of this movie, it's much like what Jeff showed, is beware of what you correlate your ground-based networks with when you have a Liz overpass. I'll take a few minutes in my talk and show one of these, and I call them Monty's movies. They're really great, but it's not Monty Python. So the results are that the previous analysis done with the Northern Alabama LMA and the CHUVA correlate equivalently with Liz. They're very happy with the equivalence of those two data sets. That's meaningful. All the basic statistics are the same: shape, size, location, flash rate, everything falls into the population that they've seen over and over again in the U.S. This means that CHUVA data should have exactly the same kinds of analyses and behavior if you simulated it using Monty's proxy tool. That's good. And now we can use that Sao Paulo data and all the local networks and say we have a reference equivalent to what's understood in Huntsville about this, and start to get to the hard task of proxy data from all the various LF networks. So I think that's it. Thank you.
Questions?
I just would like to comment that the region is also well covered by Meteosat second.
Deployed in Brazil.
Here. Repeat the question, please.
Go ahead.
Oh, repeat the question.
Which?
Or the comment. We couldn't hear.
Was the microphone not on? He'll give it a replay. Can you hear me, guys?
Yes.
Okay, I was comment that Meteosat second generation cover the region. As soon as we have the virtual lightning image, we can provide images for the 12 Meteosat second generation channels.
So that's also a proxy for what GOES-R in general, more broadly speaking, will be doing.
Yeah, for ABI.